Arithmetic operators in order of precedence. Uh, when we're doing mixed expressions, you'll find that your operators, multiplication, division, modulus, which is the remainder, addition, and subtraction, have what's known as a level of precedence. Multiplication, division, and mod have a higher level of precedence than addition and subtraction. So if you had a bunch of operands and you were to multiply and add, multiply here, uh, the multiplication will take place first and then the addition would. And it's doing it from left, reading it from left to right, just like plain old basic math. And if you wanted to destroy that order, to do a different order, you'd use parentheses in some way. Okay. You also have what's known as compound operators. Compound operators allow us to write concise assignment statements. So let's say y equals y plus 1. So here we can say y plus equals 1, which results in the exact same thing. These are interchangeable. As a fundamental student, I recommend writing it this way. And over time, you'll find out why compound operators exist as you get into coding for a living. Here we have what are known as the increment and decrement operators. They each have their pre and post, increment being increase and decrement decreasing. Pre and post, what we mean here is we can say plus plus x or x plus plus. And then if we were to say plus 1 here and then plus 1 here, right? What it actually says, do that. Well, what happened here in the pre-increment is that your variable here will increase and then the expression is evaluated. While in post-increment, your expression is evaluated first and then x is incremented. Here we have the string type. It's just, we're just going to talk about because sometimes we do use it in the very beginning of our course. We'll get into greater detail on the string type at a later time. In order to use a string data type, you have to access the library. If you recall, we talked about the preprocessor directories. Okay, the preprocessor directories that require us to have a header file name, include, and in this case, string, for us to utilize the string type. Your string data must be enclosed in double quotes. The first position is 0. Spaces are counted, and the length of the characters is the number of characters, including spaces that may be within the string. You'll appreciate and understand that at a later time when we really work with strings outside of just inputting a string and outputting it, where we count it using loops, etc. Here we talk about inputting data into our program. We talked about outputting standard output earlier. Now we're going to input it by using our standard input device, which is usually the keyboard. We use a cn command with what's these arrows or brackets going this way, which is known as the stream extraction operator. When we see out something going this way, this is known as the stream insertion operator. It's easy to get them confused when you could think see out, shouldn't that be extract? Just remember, if you're inputting something in, it's called the extraction operator. If you're outputting something out to your monitor, it's called the insertion operator. When you're inputting data into your variables, it's important that if you're inputting more than one value, let's say you're inputting 1 and 2, that you leave a space between the 1 and 2. If you just go 1, 2, the computer is going to automatically assume that or C++ is going to assume that you're entering 12. Okay, let's look at an example here. We've got include IOStream, and this time we have include string. Don't forget, if we're going to use a string type, we need to include the header file for it, our preprocessor directive. Using namespace standard, int main, here's our main function. Professor Snape gave Harry and Hermione the same numbers and operators to use. Snape wanted to see who would have the highest number after combining all the numbers and operators. So here we declared Hermione and Harry, both int data types. We also declared a string data type, magical statement. We assigned it a value, abracadabra. We also said and declared a beat Hermione data type here, int data type identified by beat Hermione. So here's Hermione and Harry. They all have the same digits, and they get 3 addition operators and 1 multiplication operator. So Hermione uses the multiplication operator towards the end, while Harry uses it towards the beginning. Well, the multiplication is a higher level order of precedence, if you recall. So therefore, it's evaluated first, and then from left to right, 1 plus 2 plus 3 is added. All right, Harry decides to multiply 1 times 2 first, and then plus 3 plus 4 plus 5. So see out Hermione's file number was, Harry's file number was, let's go ahead and run this. 26 and 14. All right, all because of the higher level of precedence in terms of multiplication, and Hermione placed it towards the end while Harry placed it towards the beginning. Now we're going to have Harry pull a rabbit out of the Half-Blood Prince's book. So we're going to say cout, enter how much Harry wins by. All right, so Harry could win by, let's say, CN. Okay, we're going to use CN, and if you recall, this is the stream extraction operator. Beat Hermione. I'm going to enter that value in by 1. When I enter it in, what happens is Hermione's value is here plus 1, which is beat Hermione. So this, don't worry about what this is, this conditional structure statement here. What happen is, if you recall, Hermione already had a higher number than Harry. So once Harry has a higher number, this loop is going to break. So what we're going to use here is Harry plus plus a post increment operator, which is different from pre, but because we don't have an expression with other operands, it really doesn't matter. But this post increment operator is the same as saying Harry equals Harry plus 1, or if you remember this, our compound operators, Harry plus equals 1. I'm going to say cout Levioso because Harry doesn't spell to beat Hermione, because Hermione's book smart and Harry is Harry. It's going to say Levioso, and then the magical statement, which is our string, abracadabra, is going to say it this many times after pulling a rabbit out of Half-Blood Prince's book, which is our final cout statement. Harry's final number was Harry, and L. Final number was 27 because we wanted Harry to win by 1. And then the rest you know, system pause, return. So let's go ahead and summarize everything that we've talked about. We started out talking about the function main. Okay, that a function basically performs a particular task for us, and that a program typically contains more than one function. All right, to preprocessor directives, which are basically things that someone's written for us that we can use, that we access by doing this. Okay, we can output things to our screen by using the cout. Okay, and then by using the stream insertion operator followed by an expression and or manipulator. We talked about the different data types. We kept our conversation on simple data types, which can branch out into multiple different types of simple data types. We talked about variables and how we declare variables by their data types and assign them a value. With constants, we initially assign them when they're declared, and they don't change, versus variables, and we talked about why earlier. We talked about arithmetic operators in order of precedence, okay, whereas these particular operators have a higher precedence than these operators here. We talked about compound operators and how they can save us time, all right, but we don't recommend them now because we're learning it. You're talking about increment and decrement operators. They can be pre or post, depending upon when we want that value to be increased or decreased if we decrement by in a mixed expression. We talked about the string type and also how that we're going to revisit this without a doubt later on. And then of course how we input data via our keyboard into our program so that it can be manipulated and have tasks done to it before it's outputted. That's it on the basic building blocks of C++.